Imagine an industrial frontier of truly epic proportions. We're talking massive open pits carved straight into the earth, vast underground labyrinths plunging into total darkness, and these multi-ton autonomous machines moving thousands of tons of rock. To the naked eye, it just looks like a triumph of pure brute mechanical force. But keeping this entire unforgiving operation alive is an invisible, highly engineered nervous system. These are the hidden communications networks that actually make modern mining possible.
A mine network is judged by consistency under stress, not by speed in perfect conditions. Think about that for a second. In our daily lives, a dropped Wi-Fi signal means, a video buffers or a web page doesn't load. It's a minor inconvenience. But deep underground or at the edge of a massive pit, a dropped signal means a drill loses its exact coordinates. It means an autonomous haul truck just stops dead in its tracks. Or worse, an emergency worker alert goes unheard. The stakes here are entirely different.
Part 1. The extreme environment. Okay, let's dive right into this paradigm shift. In our everyday lives, we tend to view wireless as a shared convenience, right? Something built for broad, predictable spaces. But for a mine, it's a critical utility. It's designed specifically for one single site, built primarily to handle heavy machines and workers operating in incredibly harsh spaces. It isn't just a nice-to-have, it's a fundamental requirement for safe operations. We really need to stop thinking of wireless as this invisible cloud of internet access and start treating it as a controlled utility. Think about it just like the electricity powering the drills, the water used for cooling, or the ventilation systems pumping breathable air down a shaft. You don't stand in a deep shaft hoping the ventilation just magically works today, do you? No, it's meticulously planned. The wireless network is exactly the same, a deliberately engineered utility that is absolutely essential to the mine's entire operating system. Part 2. Engineering the nervous system. The conditions in a mine are practically alien compared to an office building. You've got millions of tons of dense rock blocking and reflecting radio signals. You have narrow, twisting tunnel paths. Up on the surface, those open pits are constantly shifting shape as the earth is excavated. Add to that the constant choking dust, extreme vibration, and massive metal vehicles moving unpredictably. One standard transmitter absolutely cannot magically fit these constantly changing geometries. The network literally has to be molded around the rock itself. Now, what's really interesting about this is how this environment completely redefines what we consider fast. Usually, we judge networks by throughput, like a wide highway. But in a mission-critical setting, latency is the true measure of survival. It's exactly how quickly a specific message gets from one place to another, totally regardless of the size of the data. To vividly picture why latency completely trumps throughput in a mine, imagine two couriers. The first courier has massive throughput. They load up a huge truck full of thousands of packages, but they only leave the depot once a day. The second courier, they only carry one single tiny envelope, but they deliver it immediately, the literal second you hand it to them. If a machine is about to collide with a rock face, or a worker is sending a life-or-death emergency signal, you don't need that huge truck. You absolutely need that second courier. Timing, not volume, is everything. Part 3. A chain of connected jobs. So how do engineers actually construct this bespoke communications layer? Well, the architecture requires a completely different approach, built as a sequential chain of connected jobs. First up, engineered coverage ensures the signal actually exists. Second, continuous mobility ensures that signal doesn't drop when a multi-ton truck moves. Third, traffic prioritization makes sure the urgent emergency signals beat out routine maintenance logs. And fourth, built-in security protects the operational data. This is quite literally a chain of survival. If just one single link breaks, like if you lose coverage or security is compromised, the whole operation fails. And this brilliantly illustrates the concept. Engineered coverage operates much like stadium lighting. You don't just put one giant light bulb high in the sky and hope the whole field gets bright. You take dozens of specialized lights and aim them precisely at the pitch, the walkways, and the exits. My networks do exactly this, but with radio waves. The signal is deliberately targeted along the haul roads, aimed directly down the tunnels, and focused squarely on the crushers where the heavy work actually happens. Of course, the physical environment totally dictates the shape of this network. In an open pit mine, the main challenge is vast distances and moving fleets across wide areas. So the response is broad, mobile coverage using elevated towers.
But in an underground mine, the challenge is rock walls, sharp bends, and segmented spaces. The response there is distributed coverage. Equipment is physically installed all along the tunnels to carry that signal deep into the earth. Yet for both types of mines, the ultimate goal is exactly the same: reliable, prioritized communication.
Part 4. Command and control. So all of this highly engineered field equipment feeds back into one central nervous center. The network gathers millions of data points and projects them onto a single board, creating a shared operational picture. It shows exact equipment locations. It alerts us if workers are in dangerous proximity to autonomous machines. It verifies if routes are clear and constantly monitors if a machine needs maintenance way before it breaks down. By illuminating the entire system with real-time information, the network drastically reduces uncertainty.
So, the crucial point is this: a private network isn't just about technical specifications, it is about absolute ownership. When the mine owns the network, it controls exactly what gets priority, ensuring predictability and uncompromising security. The network becomes the vital bridge between human decision-making and precise, heavy machine action. It makes a totally chaotic environment entirely legible.
Part 5. The future of the frontier. A private wireless mine network turns a difficult site into a coordinated site. It is an awe-inspiring transformation, really. It turns an unpredictable, dangerous excavation into a synchronized, highly data-driven ballet of heavy industry.
We've seen how engineered radio waves can tame shifting rock, choking dust, and immense machinery. So as this ultimate nervous system comes fully online, completely eliminating blind spots and connecting human intent with autonomous power, what limits of extreme engineering will be conquered next?